Okay, hello everyone. So I'm going to do this in two videos just because I don't want one really long video. But first, before I start, I would highly suggest you pause this video and solve this problem on your own. It'll just make it, I think, a little more easier doing a tutorial if you already have the problem solved. So pause the video and solve this on your own. Okay, so now that you've solved the problem, you should remember from class that when you have a definite integral and you have to solve it with integration by parts, then you first want to solve the antiderivative, right? And so what we're going to do, and like I said in class, use the copy and paste as much as possible. So we just want to take off the bounds because we want an antiderivative. Okay, so we have that. And then, so now we're going to do integration by parts just on this. And so we need to do a new row because we want to set up our substitution. So we're going to let u equal, lovely integrals are terrific everywhere. Yes, they are. So u is going to equal natural log of x. Okay, and then du then will equal dx over x. Okay, or 1 over x times dx. They should take both answers. Sometimes with coefficients they don't, so just be mindful of that. And then in class, I think I went to a different row, but since these are arrows and not equal signs, we can stay on the same row. But remember, again, you have to state your v first, so that's another reason why it's important to already have the problem solved, so you'll know what your v is. And then your dv is x dx. Okay, so there we have that, and I'm going to do a new row so I can do my integration by parts. And if I did this correctly, which I believe I did, we will get x squared times natural log of x over 2 minus the integral. I don't know if you guys know what I just did. So minus, instead of going to the integral symbol to the right, you can just put int. And it does that. So I really like those shortcut keys. And I'm going to write it out. I'm going to write it out like this first. So x squared over 2 times 1 over x. Close that, dx. And I'm actually going to simplify. So once you simplify, which you should have, we can pull the 1/2 out front. And this simplifies to x dx. Okay, so now, and we just keep going, so we integrate that. And so our final answer, we should get, the first term stays the same because it's already integrated. We get 1/4 x squared, and don't forget your plus c. And this is our final answer. Add to final answer and submit. No, it's not right. I'm just realizing it is not at all because this is a definite integral. Yes, I wanted to get done too fast. So we are not done yet. All right. So now, but we have our antiderivative. So new row. So now the bounds, remember for integration by parts, the bounds do not change. So I'm just copying and paste my antiderivative. Paste. Okay. And we're going to evaluate it from 1 to 2. So we don't have to worry about, we go back to x, right? So we don't change any bounds. So it's from 1 to 2. So you highlight your antiderivative. This right here, this key over here, that's the evaluation symbol. And you evaluate from 1 to 2. Okay. And once you simplify that out, you should get 2. I'm not going to write it all out. 2 natural log 2 minus 1 plus 1/4. And if we go a little further to simplify that, our final answer will be 2 natural log 2 minus 3/4. Okay. Now, I know some of you might ask, well, what if we stopped here? As you all know, I want you to simplify as much as you can. But if you stop there, you should be correct as well. So let's see. Let's add that to our final answer and see what happens. Submit. Yes. Very good. Okay. So hopefully this made sense. This is without using any action. we just needed to know the notes, that symbol for evaluation, but we didn't use any action symbols. So now I'm going to do another video and show you how to do the same problem using some of the action keys.